Suppose a car moves from point X sub I at time t sub I to point X sub f at time t sub f in the amount of time shown by the clock. The average velocity of the car is the displacement divided by the change in time. Since the car is traveling to the right, the sign of the displacement is positive and is equal to x sub f minus x sub I. The time interval is always positive and is equal to the final time minus the initial or starting time. The average velocity can be a positive or negative value because the displacement can be either a positive or negative value. Even though the motions of these two cars differ, at time t sub f they have the same average velocity because they underwent equal displacements in the same amount of time.
Velocity is the change in displacement of an object with time. The speed and the direction of the object's motion must both be specified in order to describe a velocity. If another object is moving in the opposite direction, it has the opposite velocity. Another way to specify that the velocities are opposite is to use a negative sign. Sometimes a direction is not explicitly stated. In these cases, the direction is dependent on the coordinate system. Speed, on the other hand, is just the magnitude of velocity, and so it cannot be negative. Speed is the scalar version of velocity, just as distance is the scalar version of displacement. The first thing you need when setting up a sign convention for velocity is a defined axis system, with time along the x-axis and displacement along the y-axis. For motion in one dimension, velocity is positive when the object moves in the positive direction on the defined axis system. Since the position value is increasing, the graph slopes upwards. Velocity is zero when the displacement stays constant. In other words, the position value does not change. This line has zero slope. Velocity is negative when the object moves in the negative direction on that axis system. This line has a negative slope. The average velocity of an object can be determined if its position is known at specific times along its path. We calculate average velocity by dividing the change in distance by the change in time. We can also determine average velocity using a graph. Time is plotted on the horizontal axis, and position is plotted on the vertical axis. As the car moves, we note its distance from the starting position. After 15 minutes, the car has traveled 6 kilometers. We can determine the average velocity between any 2 points on the graph by drawing a straight line between them. The slope of this line indicates the average velocity between the position. The motion of this gecko can be described by imagining a meter stick placed under the gecko to define a frame of reference.